Oh, hello there. My name is David Liu, and I'm here for World MoveIt Day. No, wait a sec. I do navigation. I'm not supposed to be doing stuff with arms and whatnot. Get that. What I'm going to show you is how to use MoveIt for navigation, allowing you to control your base with MoveIt. This work is done in collaboration with the fine folks at Hello Robot, who have this wonderful platform called Stretch. And this low-cost platform has limited degrees of freedom. So what you need to do is to use the base in conjunction with the robot arm in order to achieve complex grasps and manipulations. And so we're going to take advantage of one of the lesser used features of URDF, the planar joint, which allows for motion in 3 degrees of freedom, x, y, and theta. We define a virtual joint between our ODOM frame and the base of the robot, use a custom inverse kinematic solver, and then the rest of the MoveIt library will just create plans for you using those new degrees of freedom. The real problem is that the planar joint assumes that your robot is holonomic. It can move in any direction. And so not only will it move forward and turn, but it also assumes that you can just slide to the side. And that's kinematically infeasible for diff drive robots such as this. So what I'm working on this World MoveIt Day is to extend the semantic robot description format to include a new diff drive joint that will generate motions that will first turn towards the destination, then translate, and then turn towards the target orientation. Then we'll be on our way to being able to generate MoveIt plans using the whole MoveIt stack to create kinematically feasible plans for our diff drive robots.